matrix multiplication. So to do matrix multiplication, you need two matrices. Say A is equal to 1 1 2 1. This is first matrix and this is the second matrix. So 1 0 1 1. If we want to multiply, first of all check the order. This matrix is 2 rows into 1 2 2 column. This matrix is 1 row, column 1 2 3 4, 1 by 4. This is 1 by 4 matrix. This is 2 by 2 matrix. So 2 by 2 matrix can't be added to 1 by 4 matrix. For matrix multiplication, the number of columns in this matrix should be equal to number of rows in this matrix. So these two must be equals. Number of columns of A should be equal to number of rows of B matrix. So this is the basic criteria. So these two matrix can't be added. So if we take x is equal to 1 2 and y is equal to 1 1. So this is number of rows in this matrix is 2 1 2 2 row, and number of column in this matrix is 1. In this matrix, number of rows are 1 and number of columns are 1 2. So you can see that the number of columns of first and number of rows of second are equal. 1 is equal to 1. So these two matrices can be multiplied. It means you can calculate x into y, that is x into y. Y is 1 comma 1. So in this case, how the multiplication is performed? It is not performed just like addition and subtraction. Here we take the first row and first column. First row and first column. This will be multiplied by this. 1 is to 1. Then first row and second column. First row and second column. That is 1 is to 1. Again, we will have to take first row and multiply it with the first column. So this will be 1 into 1. Again take first row and second column. First row and second column. Now we have reached the end of column of this matrix. Now go to the second row. Second row, first column. 2 is to 1. Second row, first column. Then second row and second column, 2 into 1. So it means 1 1 2 2. This is the multiplication matrix. If we multiply this x by this y, you will get this as result. So from the given matrices, you can calculate what will be the resultant matrix. This will be this multiplied by this. So one is number of column and number of rows of these matrices are common. The rest of the two which shows the number of rows of first and number of rows of column, that will be the resultant matrix, that is 2 by 2. This is how the matrix multiplication can be done. You can take another example. Say P is equal to 1 1 2 0 and Q is equal to 1 1 2 1 3 0. So this is 2 by 2 matrix because it has 2 rows and 2 columns. This is 1 2 3 3 rows and 2 columns. So it means number of columns of first and number of rows of first does not match. 2 is not is equal to 3. So these two matrices cannot be multiplied. It should have equal number of rows of this, columns of this must be equal to number of rows of this. So if we change P to this 1 1 1 2 0 1, and Q will remain the same, 1 1 2 1 and 3 0. So this is the Q matrix. So now this is 2 by 3 matrix, this is 3 by 2 matrix. So 3 rows and 2 columns, 2 rows and 3 columns. So this is equal to this, means 3 is equal to 3. So multiplication is possible. So in PQ you will get 1 1 1 2 0 1 and 1 1 2 1 3 0. This is equal to first row and first column. You have to multiply 1 into 1, then 1 into 2, then 1 into 3. Okay, then first row and second column, this 1 into 1, this one is multiplied with this 1 into 1, then 1 into 0. Now this is over. Now go to the second row. Second row, first column, 2 into 1, 0 into 2, 1 into 3. Now second row and second column, 2 into 1, this 2 into 1, then 0 into 1, 0 into 1, then 1 into 0. So just calculate this. This will be 1, 2, 3. 1 plus 2 plus 3. Then 1 plus 1 plus 0. 1 plus 1 plus 0. Then 2 plus 0 plus 3. 2 plus 0 plus 3. 2 plus 0 plus 0. So 0 plus 0. This is equal to 6, 2, 5, 2. So this will be the multiplication of this P and Q. So as we know that the result will always be this multiplied by this 2 by 2 matrix. So this is 2 by 2 matrix. So this is the multiplication of matrices.